Begin by turning on the computer and mounting the calibration arbor on the machine. Attach the encoder directly to the arbor by sliding the U-joint onto the turned-down portion of the arbor. Secure it with the 2 set screws. Make sure that the arbor is centered as closely as possible between the 2 columns. This positioning is crucial for accuracy during calibration. With the software open, rotate the part by hand to verify that when it is spinning in the same direction that the motor will spin the part, that the green arrows or the gauges on the screen are rotating clockwise. If it is spinning counterclockwise, then you'll need to go into the gears and check the box next to Reverse Direction. Note, if you are using a photo eye pickup instead of the encoder, you can ignore this check. Once the direction is confirmed, spin the part up to what your normal balancing speed will be and press the measure button located in the lower left-hand corner. After taking the reading, stop the part. The specific reading value doesn't matter at this point. The goal is to ensure that you are getting a reading. To verify that both sensors are plugged into the correct slots, you can unplug one side, and the dial on that side should go to 0 or close to it when you take another reading. If everything checks out, you can proceed to the next step. This verification is essential to avoid calibration errors. Press the gears icon located in the lower right-hand corner. This action will bring up your settings page. At the top right corner of the settings, you will see 2 buttons, Clear Sensor Data and Map Sensors. Press Clear Sensor Data and then press Yes when prompted to confirm. Next, press Map Sensors and then close the settings page. The sensor mapping process involves taking a series of readings so the software can identify the phase shift of your machine and sensors. It is recommended to start with a reading at 300 RPM and then take readings every 50 RPM up to around 800. If the arbor starts to bounce or rattle at any point before reaching 800 RPM, don't take any more readings as this can affect the mapping. After taking the highest speed reading, press the gears icon again and press Map Sensors once more. This will close out the procedure and set the curve for your sensors, ensuring consistent angle readings between those speeds. After completing the sensor mapping, you're ready to calibrate. Start by rotating the arbor so that the weights are positioned directly at the 12 o'clock position. Once they are here, press Set 0 in the lower left-hand corner of the interface. This step informs the machine that the 0 position is where the weights are, which is crucial for accurate calibration. Next, verify that both the left and right radius numbers are set to 2 inches if using our standard calibration arbor, and the offset numbers will both be set to 0. These values can be found in the lower middle part of the screen. If necessary, press or click on the text box to bring up a keypad to adjust these numbers. With the numbers in place, you can spin the part up to your most common balancing speed. With the part spinning at speed, take a measurement. The numbers on each dial will display the unbalance at that particular radius. Open the settings box again by pressing the gears icon. Locate Known Mass in the center toward the top. Enter the number written on the calibration arbor, usually around 46 grams, in both the left and right boxes. If no number is written or you want to verify, you can remove one of the test weights and weigh it on a gram scale, then input the numbers into the box. Just below Known Mass, you will find another pair of boxes for Known Angle, which should both be set to 0. Once these numbers are entered correctly, press Calibrate above those boxes. Afterward, close the settings page. Spin the part up to your calibration speed again and take another reading. The numbers on the left and right plane should now be within approximately 0.3 grams of what is indicated on your arbor. If the numbers are not within this range, press Calibrate again and take another reading. Repeat this process until you are satisfied with the reading, taking multiple spins to verify that it's maintaining. The angle should read 360 or 0 after calibration. You can repeat this process for additional speeds. Typically, 300 and 600 are used for crankshafts. However, some may choose to calibrate every 100 RPM between 300 to 700 or so, depending on specific requirements or preferences. The lower speeds allow you to spin up parts that are farther out of balance with usable numbers, while the higher speeds allow you to balance lighter parts with more precision. Once you are satisfied with the calibration numbers, open the settings page once more and click the checkbox below the calibration speeds that says Select by RPM. This setting enables the software to automatically select the closest calibration speed when you choose to take a fresh reading. In the left column, there is another checkbox next to Measure Automatically. Set the value to your most common balancing speed and check that box so it will auto-sample when you're close to that speed. This number can be adjusted at any time, but it's recommended that it be left on your primary balancing speed. After completing all these steps, you can press Save Calibration located in the lower right-hand corner of the settings window. Then, hit Save at the bottom of the box that pops up. This ensures that your machine is now calibrated and ready for the balancing process.